Day late. All right. The graph opens up. Hayden says when the number in front of the x squared is what kind of a number? Positive number. So maybe I can just say when a is positive. If you really like symbols, what symbol would you write to show that if like a is a positive number? A greater than 0. Sure, if you really like math symbols, you can do that. How about when we open down? That's like a frowny face. Or a is negative, or a is less than 0. Not so bad. You already told me that. Okay, this is something maybe you don't know yet, so I'm going to go ahead and go to Desmos. Give me your favorite. Shut out some numbers. 7x squared. Oh, gosh. 7x squared plus 14x, and then I heard a 20, plus 20. Okay, y'all are making me zoom out. Do you know how to adjust the domain and range? No. Let's do like 7, and then -7. Okay. Y-intercept. That's where this crosses the y-axis, right? Can you see this okay? You can? Where does this cross the y-axis? At 0, 20. Do you see a 20 in that equation? Yeah. Do you think that's always going to be that number? No? Well, 5. Okay. Here's 5. What if it's like a negative number? Let's try to mess this thing up. Give me a negative number.
-2.
-2? Is the y-intercept -2? I wonder if that's always the case.
But what if you do it into parentheses so it moves it to the left or right?
So you want to throw something in these parentheses?
Yeah.
What do you want to put?
6.
-6? And then same with this one.
So now that intercept is going to be different.
That's true. And y'all, that's a good point. These patterns only work if you have it exactly in this form. So that means we don't add or subtract anything into those x squares. So it's already like simplified for you. Does that make sense?
Yeah.
Okay, but thanks for bringing that up, Ellie. I really do appreciate that. Okay. So the y-intercept is just the value of c, the letter c. Exactly. Okay. And now something a little bit different. And this pattern is kind of harder to see unless you kind of are told it. So you see this vertex? Desmos tells you the vertex, right? That's nice, right? I'm going to tell you that the formula for the vertex, or the x value of the coordinate, oh my gosh, what? The x coordinate of the vertex is x equals -b/2a. So in this function, 7x squared plus 14x minus 2, what's your a value? 7, yeah, it's a 7. So I'm just going to write this in Desmos just so you can see it, and so the online people can see it. Why did I write 0? You told me it was 7. What's b?
14.
If the x coordinate of the vertex is x equals -b/2a, and our a is 7 and our b is 14, that means our x coordinate is, all right, yes, -14 all over 2 times 7, right? Which is -1. Desmos even tells us that. Hey, class. Do you see that purple line that was just graphed?
Yeah.
What else is true about that line?
It's on -1.
It's on -1. It goes through the vertex.
It's the line of symmetry.
It's the line of symmetry. Therefore, the x coordinate of the vertex is
The line of symmetry.
also the line. So like x will equal -b/2a, and that's also the axis of symmetry. So the answer is the same for both these.
Wait, what's the y-intercept value?
C, whatever C is, that'll be your y-intercept. I just told you.
Oh, so it's like a...
It's just a pattern that's always true no matter what equation you have. Yep. True, true, true. What questions do we have so far? Maybe you can guide me through this next. Graphing 3x squared plus 4x minus 2.
Graph opens up because the number's positive.
Graph opens up. What does open up mean?
Above, it opens on the positive side of the graph.
It just means that it's shaped like a U,
Yeah.
like a smiley face, not a frown face.
Because A is positive.
Yeah, because A, which is A is 3, and 3 is positive. I'm going to write 3 is greater than 0, but if 3 is positive makes more sense to you, then you go ahead and write that instead. All right. Where is this thing going to cross the y-axis?
-2.
-2? What's the point?
-2, 0.
0, -2, you mean?
Yeah.
Yeah. Cool.
Right on.
Right on. Not too scary. What is the x-coordinate of the vertex? Oh, dear. -b over 2a. What's b?
4.
And what's a? A is 3, b is 4. Therefore, the x-coordinate of the vertex is -4 over 6, which is, okay, I'm going to write it out just for the sake of being clear, which is -4 over 6, which is -2/3. I already heard that, so y'all are doing okay. Should we double check that in Desmos, or do you trust the math?
I trust it.
I don't know why that's always your answer. What's the axis of symmetry?
Same thing.
Make sure you write x equals. This is an equation, so x equals -2/3. That's our axis of symmetry. But cool. When I found the x coordinate of the vertex, that's also the axis of symmetry. Cool. Is that it? Or do we have more to find? Oh, okay. Maximum value. Can I graph this real quick? What is it? 4x squared?
It's 3x squared.
Oh, it's 3x squared.
3x squared plus 4x minus 2.
What's the maximum value? There isn't one, is there? Do you think maybe I just made a mistake in the notes? And do you think maybe I meant the minimum value?
Minimum, yeah. It was negative.
It was negative.
Yeah, if it was negative, then we would have a maximum. You are right. But I just wasn't careful enough. I didn't attend to precision.
You didn't what?
Attend to precision. Man, this mask. What?
Didn't pay attention.
I didn't pay attention. That's a layman's term to say it.
I've been done
I was trying to say.
Okay, the minimum value. All right, yeah, we can use Desmos, can't we?
Yes.
Just for the sake of, how would you find that value algebraically?
Wouldn't it
Wouldn't
be
be
the
the
vertex?
It's the vertex, and we already know the x-coordinate of the vertex, don't we?
Yeah.
How would we find the y value then?
It's just whatever, if you follow the, it starts at 0, 0, doesn't it?
Maybe.
So if it's,
It's close.
or is the y,
Hey class, if x is -2/3, how would we find y?
Isn't it the same thing?
Not always. Plug in for x. So if y, its our equation is 3x squared
yeah,
plus 4x minus 2. We could just plug in 2/3 for x and then solve for y, right? Yeah, that's a lot of fractions, right? Okay, hang on. Just write it out. Y equals 3 times -2/3 squared plus 4 times -2/3 minus 2. So you can do that in your head, right? So that's about 3 1/3. Sorry, -3 1/3. I'm just kidding. You don't. That's okay.
I do not get what you just did.
Just write Desmos. Y equals -3 1/3, and we'll prove it with Desmos. Just in a second. I'll let y'all finish writing here quick.
So you put the equation in, then you put x this.
Yep.
In a separate box. In Desmos. Or do you have to put that equation with the 2/3?
Oh yeah. Oh y'all, let's do this. It's 3 times. What is it? -2/3. Is that what our x is?
Yeah. Where?
You can center it.
We can enter this into Desmos. I forgot about that. Plus 4 times -2/3, right?
Yeah, minus 2.
-2. Desmos gives us that.
And then it's the vertex.
-3 1/3, and that is just the y value of the vertex.
Okay. So is that the answer?
Yep.
Yes.
-3 1/3 is the answer. Circle that.
Y equals.
Yep. Last, domain and range. We've talked about this. Domain is how far left and how far right the graph goes.
Unlimited.
Unlimited. I like that.
All real numbers.
So, yeah, often in math we say all the real numbers. Hey class, how about the range? That's how high the graph goes and then how low it goes. Does it go?
Anything greater than-
There's a low point, isn't there? What's our lowest point?
-3 1/3.
Why did we? What is this? Oh, it's the code. This is cool.
Where's Caden?
What's
Hmm.
the code? The code
I didn't know you could open up the code for Desmos.
Yeah.
That's a lot of code.
Okay, I don't know what this is.
Oh, that's cool.
Have you seen
That's
the
sweet.
website Endless List or whatever it is?
All right, y'all. Remember, range deals with x or y. Y. So that means our lowest y value is what? -3 1/3. So the range is
Anything greater than
anything greater than -3 1/3. So y is anything greater than or equal to -3 1/3.
That's a lot of work.
Is it?
There's more.
Oh, wait, there's more.
All right, flip the page. All right, y'all. X-intercepts. What is an x-intercept?
Where it crosses the x-axis.
Across the x-axis. When we cross the x-axis, that's the horizontal one. What's the y value equal to? 0.
So it's just solving for x.
It's solving for x when y is 0.
So that's like what we were just doing.
It's exactly like what you were just doing. This is just the application of it. So, hey class, we're going to set y equal to 0. So we say 0 is equal to x squared plus 6x plus 5. And we need to solve for x. How do you do that?
You factor.
We should factor it.
So you do. Oh, all you have to do. It's not one.
No, it's not that whole process. We just factor. We just need two numbers that multiply to what?
5.
Oh.
And
Multiply to
add
5
6.
and add to 6. What are those two numbers?
5 and 1.
5 and 1. Those are your only options. So that means 0 is equal to, you tell me, x plus 5 and x plus 1. Times x plus 1, I guess I should say. Yes. Now, how do we solve for x?
You set both of them to 0. So you do x plus 5.
Wait, they're both plus.
Yep. So we said both of them equal to 0. So x plus 5 is 0 and
So just x.
That equals negative.
So x equals negative 5.
all right, I'm out of room. Are you out of room?
No.
Well, good. Good job.
X.
So this means x equals -5 and x equals -1.
those are the two X.
Those are two x coordinate or the x values. So what are the coordinates?
0, -1, and 0, -5.
Negative
No,
5, 0.
-5, yeah.
Yeah, negative 5, 0, and negative 1, 0. And those are that's your answer right here. Writing this down, Tyler?
No.
And Olivia? Ready for the notes check on Friday? Yeah, I'm going to encourage some note taking. You have any questions? You all okay so far?
I think we should kind of skip the bridge.
You want to skip the bridge?
Yeah.
Why?
Take the highway.
It looks
This is
hard.
fun.
What if I just told you that it's all you do is use Desmos and find the minimum value?
Yeah, go ahead.
That's not too bad.
Yeah.
All right, y'all. Suspension cables. These guys that go like this, like our lights, like this cord. The Mackinac Bridge in Michigan form a parabola that's modeled by this big thing, yeah?
That's a big.
Where x and y are measured in feet. What is the height of the cable above the water at its lowest point? Well, what are we trying to find here?
The lowest point.
The x value or the y value?
The X. Or no,
The
yeah,
Y,
yeah.
because you're trying to find the
Oh, yeah,
height
for-
between the water.
We're looking for the height between the water and the bridge, so that's the y distance. So we're looking for y value.
Is it 250?
Is it 250?
No,
Yeah.
2000.
Oh, no, sorry, not quite. But hey, can someone read it to me because I can't remember. It's y equals
0 point. And then you got 4 zeros.
98x squared.
Yeah, minus 0.37x plus 552.
Oh dear.
What are you doing?
Mm.
It's putting it in proportion so we can see it.
Oh yeah, do you know what I'm doing here?
No.
Do you see this little wrench?
Yeah.
You can change like your domain and range of what you can see on the graph. So I just made my x values go from 0 to, or my x is going from 328, if you can kind of see this, to about 4,000 right now. So actually, I'm going to go ahead and change that. Yeah, let's change it to 4,000. And I changed the y values too, just so we can actually see it. So did you see how I changed it once and I made a mistake and then it just looked like a line because I was too zoomed out?
We do it.
Maybe. Probably too zoomed in, yeah. Okay, and what are we looking for again?
The lowest point.
Lowest point.
Oh, well, I don't see any point.
Nope.
Hey, y'all, if you click on your line in Desmos, it just tells you. How about that?
So there's 2 numbers.
Oh, there are 2 numbers. Which one are we looking for?
The Y. So it's
The Y. So, how high are we above the water?
202.765
Feet,
feet.
right?
Yeah.
So, we use Desmos, and we found that the height of the cable above the water at its lowest point was,
200.
what was it again? 202.765.
765.
Was it that?
Yeah.
Oh, good memory. Feet above the water. What, Caleb?
For your unit of measurement.
Feet?
Yeah. I don't know. It's a big bet.
Yeah. My handwriting's not great, but thank you for the clarification.
I'm just
Is there
thinking
anything else, like-
learners.
No, I do appreciate that. If you ever can't read it, just ask y'all. I know my handwriting's kind of rough.
Is that lower part of the bridge rounded?
Well, probably
Sometimes they are.
Yes.
Sometimes you have to go up to cross the bridge.
Yes.
It's probably hard to write like that.
What?
It's probably hard to write like that. Like on your computer screen.
It's okay. I do have a nice pen. It's $11.
Wait, is it just any pen or is it special?
It's like a screen, like a stylus. All right, ready for the next one?
Why is there like a contact lens on the bottom?
Where's what?
She's secured a contact lens.
What?
On
On
the
your
bottom of your pen, it's like a contact lens.
I don't know. There are about 7 different tools I can use, and they're all, this pen breaks into a million different pieces. This is why it rattles, and you ever see me taking it apart because something's rattling and it's driving me nuts. That's all. But I found this one is the easiest to write with, this little contact lens.
You just like took out your eye.
Can you rip it off?
Have you seen those videos of the people with the contact ones?
All right, y'all. Let's keep going because remember we are on video. Task 3. All right, you and your friends are throwing water balloons. And there are 2 water balloons being thrown. The first can be modeled by the function f of t equals negative 16t squared plus 80t plus 5. And I just want to let you know that you see that negative 16? That's not random. Parabolic motion, one of the forces acting on this motion is the force of gravity, right? The force of gravity is always acting on us. That's what that negative 16 is. That's our gravitational force of negative 16 feet per second per second. If you're curious. Okay. So that represents the height of the first balloon, and the height of the second balloon is shown in the graph. Which balloon went higher? Well, how high did the second balloon go?
Really above 150.
150.
Above 150?
One,
Well, 150 would be this top line, right?
Oh,
It's like 120.
120, 130.
130, maybe 140, I don't know. I'm going to say around
Yeah, probably around
130. What's our unit?
feet.
Cool. So the second balloon went around 130 feet high.
That's an arm.
It's not too bad, right? I want them on my team. And then the first balloon, should we graph that in Desmos, or can you tell me the vertex right away? This is y equals negative 16 t squared. I'm just going to use x squared. What is it, plus 80?
Yes.
Plus-
80 plus 5.
Plus 5. Oh,
We got the other thing again.
okay. How high are we going? I think this one goes like 20. Okay. How high does this one go? Oh,
I don't know. We can click on the line.
I can click on the line and find out. How high do we go? 105.
105.
105 feet. So we graph in Desmos. And this one goes 105 feet high. So which one goes higher?
Second one.
Yeah.
Yes.
By how much?
By like 25.
So the second balloon goes about 25 feet higher. Desmos is a pretty nice tool, huh?
Yeah.
Imagine doing this without a graphing calculator. Which is what everybody had to do up until about 2 years ago. So y'all are kind of lucky, huh? That's kind of nice because we get to do more applications and understanding what this graph is instead of just the rote things, you know? It's fun for me. Y'all have any questions at this point? You kind of find the pattern, you really just graph it, and you just have to know what it means. What?
Did you frisbee golf this week?
I did frisbee golf in the snow yesterday.
Wasn't it cold?
Yeah.
What did
You and
shoot?
your roommate went frisbee golf? Who won? You and your roommate.
Not me. What did I shoot? I think I got plus.
Oh, for park.
I think I was plus 11.
How many holes did you do?
9.
9. And are they all the same?
Par
par?
3. Yeah, they're all par
They're all
3.
par 3.
I usually shoot about a 4 or 5. Sometimes I'll get a par.
Is your roommate just a master?
No, they're just a little bit more athletic than me. Because, but it's fun. Okay, is this our last one?
Yeah, but there's 3 parts.
That's not too bad. All right, yeah, what?
Nothing.
We're throwing a ball. And it can be modeled by this equation. Where x is measured in what?
Seconds.
And y is
Feet.
the height in feet. And what does the x-axis represent? Okay. What's the initial height of the ball when it's thrown? Can you tell me that already just by looking at it?
5.
5.
Yes.
Just for the you're right, it is 5 because that's y-intercept. But this is negative 16x squared.
Plus 15x plus 5.
Cool. Let's go home.
Wait, how?
Yeah, how do we figure that out?
Because it's the plus 5.
It's the plus 5 at the end. That's when our time is 0. When x is 0, we start 5 feet above the ground. So that's our y-intercept. So I'll just kind of put that in parentheses just so we all kind of know. This is really just the y-intercept. The initial height. 5, what's our unit? What's our label?
Feet.
Thank you. So we start 5 feet above the ground. That's like if I just threw a ball, like I probably normally, it's probably about 5 feet. Maybe that's why I chose that, because it's like me. All right, when is the ball at its maximum height, y'all?
8.516.
Seconds?
Feet.
Feet. Oh, that's how high it gets.
Yeah.
Oh wait, how long does it take to get to that height?
0.469.
0.469 seconds, so about half a second. Nice. So at what time is the ball at its maximum height? So at
469.
4.469 seconds, the ball is 8 point, what was that number? You don't remember? 516. 8.516 feet above the ground. Or high, 8.656, what? 8.516 feet high?
Yes.
Cool. Not too scary, right? And then, the best question. How long does it take for the ball to hit the ground?
Well, then you just go
Wait, go back to the 5. Go click on the, no, over. Go to
Where?
the next one.
This one?
No, go up.
Up.
No. Go on the, yeah, right there.
This?
Yes.
Where's the ground?
Down.
on the
Or is it on 0?
It's on 0. It's on the
Yeah, 'cause
x-axis.
he's still starting at a.
Because we start 5 feet up,
Yeah.
but the ball doesn't hit the ground when it's level. It's at the ground. So it's down at the x-axis. How long does it take to get to the ground?
1 second or 1.19.
1.198 seconds.
Yay.
And just for
1 point what?
198 seconds. And that is, remember y'all, this is your x-intercept. All right, what do you think?
It's not bad. I like this.
Yeah, it's just a lot of analyzing the graph. Can you graph this and understand what it means? That's really what it is.
I love
All right, y'all. I'm gonna pass out a learning check. You'll have the next. When do we end? 121. So 10 minutes to work on it. Sound good? And I'll be around to ask questions or answer questions. What's up, Maggie? Yes. Hey, what did you say?
That says a Flipgrid tomorrow.
Yeah,
Oh, no.
it's okay. It'll just be kind of one of these problems, like just like on the first page. All right, and I'm gonna stop recording.